This is the walkthrough for homework 3. We have our equations at the beginning. We have 1 pound is 4.45 newtons. That's a conversion factor. And 1 kilogram is 2.204 pounds, but this only applies on Earth. The reason is kilograms is actually mass and pounds are force. So this conversion factor has the acceleration of gravity on the Earth built into it. Formulas we're going to need for these problems. The distance traveled is 1/2 of the acceleration times the time squared plus your initial velocity times time plus your initial position. Your velocity at any time is the acceleration times time plus your initial velocity. Newton's second law, right? Force equals mass times acceleration. Weight is mass times the acceleration of gravity. So on Earth, acceleration of gravity is 9.81 meters per second squared. A vertical motion in a gravitational field. So the acceleration of gravity is downwards. We call g the acceleration of gravity of 9.81 on Earth. It's like 3.4 on Mars, 1.6, 1.7 on the Moon, or something like that. So the distance, the vertical motion, your height, y, is 1 minus 1/2 gt squared plus any initial velocity times time plus your initial height. And then vertical in the vertical direction, your velocity is minus the acceleration gravity times time plus your initial velocity. So let's look through some of these problems and just walk through, talk about what they are. We have an acceleration, we have a mass, right? What's the net force? Well, this is just Newton's second law, F equals ma, right? Here's our A, here's our M, F equals ma. If you have a mass of 57.81 kilograms on Earth, what is your mass on Mars? This is kind of a trick question. Why is it a trick question, right? Mass is how much matter you're made up of. So whether you're on the Earth or Mars or Jupiter or wherever, mass is the same. It doesn't change based on location. Right? It doesn't change based on location. So the answer for this one, 57.81 kilos on Earth, is 57.81 kilos on Mars. This problem, however, is different. All right, you have a mass of 80.37 kilos on Earth. What's your weight on the moon? Well, you just have to use the acceleration of gravity on the moon times your mass to get your weight on the moon. 4. If you apply a force of 121 newtons to an object and it accelerates at this rate, 17.55 meters per second squared, what is its mass? Well, again, this is Newton's second law. F equals ma, but we know the force and we know the acceleration, we just have to solve for mass, right? F equals ma. If you solve this for mass, mass equals force over acceleration, right? So FMA equals ma becomes mass equals force divided by acceleration. All right. In problem 5, we're after how long it takes for a ball that you throw, right? Take this ball, I'm going to throw it up, and it's going to come back down. And actually, I'm going to do it straight up and straight back down. That's all fine. Straight up, comes to a stop, and it comes back down, right? So I do that. And this equation, t equals the square root of 2h over g, tells you how high it's going to go, or how long it's going to take for it to get up to that height. Now that's just up. There's also back down. So when we ask how long will a ball be in the air on Earth that you throw to this height? Well, we've got h, we've got g of 9.81. We know what 2 is. We can take the square root of all of that. That's how long it takes to go up, and it takes the same amount of time to go down. So whatever you calculate from this, you simply have to double. Number 6. What is the velocity which you throw a ball upwards if it makes it to a height of 6.889 meters? 6.889 meters. All right, so we've got h, And here we're using the velocity equation. V, your velocity you throw it with, is square root of 2gh. We have h. We know g is 9.81. We know 2. So we take the square root of 2gh, right? There's h. Square root of 2gh to get our initial velocity. 7. You throw a ball up to a given height on Earth, and you throw it just as hard on Mars. How high will it go? So here's the height we throw it to, right? Well, our velocity on Earth then is given by 2 square root of 2 square root of 9.81 times that height. That's how hard we throw it. Then we just got to move to Mars. We're going to do the same thing, except now, now we know V naught, right? Because we calculated that on Earth. And what do we need? We need h, right? And we also have to go up here and we have to find g on Mars. Where's g on Mars? 3.71 meters per second squared. Find g on Mars. So we're going to find the velocity on Earth, right? Then we're going to take that velocity and we're going to solve the equation v naught, right? Because we now know the velocity is 2 square roots of 2g h, right? The g is, again, Mars, so that's 3.71. H we got to find, so let's square both sides. All right, I'm going to go over to Word, do that. All right, here we go. V naught is square root of 2gh. All right, we want to solve this equation for h, so let's square both sides. Equals 2gh, and we just have to isolate h, so v naught squared over 2g equals h. And that gives us the height we go to on Mars after we calculate the velocity we threw it with on Earth. All right, h equals v naught squared over 2g. Okay, question 8. We have a force, we have a mass, right? You apply a force to this mass. It starts at rest, right? So v naught is 0, right? Because it starts at rest. X naught we can also take to be 0 because we're not given any particular place. So we have a force, we have a mass, and we have a time, right? Force, mass, and time. And what we're after is how far will it go in this amount of time, right? Well, position is 1/2 a/t squared, right? Plus, the v naught t, well, that's going to be 0 because v naught is 0, plus x naught, which is also 0. So that's 0, that's 0. So x is 1/2 a/t squared. We don't know a, but we know f and we know m. And so a, we can solve a Newton's second law to get a is f over m, right? So we get a, we stick it into this equation along with the time, and that tells us how far this object has gone in this amount of time. Number 9. We have another force we're applying to an object. It starts at rest again, so v naught is 0. How long will it take to go this far? Now this is exactly the same thing, except we've got the distance and not the time, right? So I'm going to start with where we left off last time. On the previous problem, we've got x equals 1/2 a/t squared, right? X equals 1/2 a/t squared. Now here we find a from Newton's second law. A is force, the force divided by the mass. That's a. We don't know the time, but we do know the distance. So we know the distance. We can calculate the acceleration. We need to find out the time. All right, and then v naught is 0, so that term is 0. There's another term out here, x naught, that's also 0. So let's go back over to Word. Let's take a look at this real quick. So we've got x equals 1/2 a/t squared, right? And we want to solve for time. So I'm going to multiply by 2 and divide by a and get me t squared, I'm just going to take the square root. 2x over a. All right. So now we get a from Newton's second law. We know x. We can find out the time it takes to go that far. All right. Straightforward. Number 10. You have a Honda Civic along with passengers that weighs 1375 kilos. How much force does it take to achieve the acceleration needed to reach this velocity? All right. So we have a velocity and we have a time and we have a mass. All right. Now we have an equation v equals a t plus v naught, right? So how long does it take to reach that velocity? V naught is going to be 0, right? 0. V naught is 0. A, well, how much force? We're after, we know V, right? We know T, we can find A, right? So A we're going to get from V over T, oh, right? A is V over T. Once we have A, we use Newton's second law to get the force. All right, F is ma. F is ma. Right? We get A from V over T, and then we've got the mass, we've got the acceleration, F equals ma. And that's it for the walkthrough on homework number